All right, class. Today, my goal is to try and show you guys through a video of the markings you might find on a rigid tube in aviation, what those markings mean, and then finally, we're going to do 3 practice calculations on inside diameter, outside diameter type of calculations. So, first, this is a tube. It's just got some generic markings on it. The first part here, and as you can see right there, the first part is Alcoa on this one. It's just a brand name. It's who built the tube. The second, if you remember back from Structural Materials and Processes, the 5052 is an alloy code, is an aluminum alloy code or composition code. And if you look through this PowerPoint, it's going to tell you which composition code is used for which pressure ranges and some common applications for those particular compositions. So if you were to look later in the PowerPoint, for example, 5052, you would see right there, used in low pressure fuel and oil systems and so forth, and also used in medium pressure hydraulic and pneumatic lines and so forth. So I'll let you guys read through that on your own. The O, that is the degree of temper. If you remember, O means annealed, which is common for tubes because if they're hardened, it's difficult to bend them without them breaking. So a lot of times they are in the annealed state, so this is an O, but you might see things like T4, T6, if you remember what that, what all that coding is about back in the heat treatment process we went through. And then finally, the next thing, these are the most important things, are what we're going to spend most of our time on. The -6 relates to the size of the tube. When we talk about rigid tubes, we're talking about the sizes are going to be in 16ths of an inch. So, for example, if that's a 6, that should be 6/16, or 6/16 reduced down to 3/8. So this is a 3/8 outside diameter tube, and what that means is the outside diameter. So if you were to grab a pair of calipers or something, or a micrometer, measure on the outside of the tube, it would be 3/8. And then the last thing is the wall thickness. I'm going to use an illustration I've drawn here on this paper down by my computer and to help explain wall thickness. In this case, it's 49 thousandths is how you'd say that. 0.049 is 49 thousandths. So down here, I have an example of a tube. It's Alcoa, that's the brand name. The 5052 is the composition code. The O is the annealed. The 6 is a 6/16, or also known as 3/8 tube. And then finally 0.049 would be the wall thickness. What we're going to do is we're going to use this information and try and solve the question of what would be the inside diameter tube of the tube. So what does that mean, the inside diameter? That means like if you were able to take a tool, a measuring device, and measure the inside of the tube. This is an end profile of the tube. This is the actual tube. This is looking at it from the end view. What that means is the wall thickness is 49 thousandths. The inside diameter is what we're trying to solve. So if you think about it, if you know the outside diameter right here, if you know that if I squash down on this with a pair of a micrometer or caliper, I would get 6/16 or 3/8. What I can do is I can say, okay, well, if the whole thing's 3/8 and the wall thickness is 49 thousandths, if I take that 3/8 and subtract this wall thickness and this wall thickness, what's left over would be the ID, or the inside diameter. So the way to do this is you'll take, basically you're going to take 3/8, and I'm going to go ahead and use the decimal equivalent of 3/8 to make this a little bit, the math just a little bit easier. So the decimal equivalent, if you took 3/8 and turned it into a decimal, it would be 0.375, okay? So what that 0.375 means, that is the outside diameter. Now the wall thickness is 49 thousandths, but if you notice, there's one wall thickness and two wall thickness in any time you measure across this tube, which is called the diameter. Anytime you measure across the tube, you're going to have two wall thicknesses included in there. So if I wanted to know the ID of this tube, I would have to take the 0.375 outside diameter, and I would have to basically subtract the wall thickness twice. I would have to say, okay, that minus the wall thickness in this case was 0.049, and then minus 0.049 again. And what you would see, and I'm sorry if that came off screen, I'm trying to do this the best I can. If I did all the math and I did it ahead of time so we could see this, that means that the inside diameter of this would be 0.277. It's always easy to check these on the inside diameter questions because you can take your final answer, add the wall thickness twice, and you should be back up to the outside diameter, which is this -6 on this tube. So the final answer on this one would be the 0.277 would be the inside diameter. And like I said, you can double check that by adding wall thickness. So I'm going to try one more example of this same type of problem, and then we're going to work backwards. So here's another tube. It's an Alcoa, brand name, 2024, composition code. O is annealed. 8 is the outside diameter. 8/16 would also be the same as a 1/2 inch. And then times 0.032 would be the wall thickness. So what we're going to try and figure out is what would be the inside diameter of this tube. Well, in order to do that, we would have to say, okay, well, this wall thickness is 0.032. This wall thickness is 0.032. The outside diameter is 1/2 inch. So the math on this would be, you take the 1/2 inch, 0.5. You're going to subtract the wall thickness 2 times, 0.032. 0.032. And when you get all done solving this one, it would end up being 0.436, the inside diameter, if you were to measure across this inside of this tube. So, but again, I can double check that by taking the 0.436, add that wall thickness, add this wall thickness, and I would end up being 0.5, which that 0.5 is the same as, that's the decimal equivalent of 8/16 or 1/2 inch is the decimal equivalent. That's where I got the 0.5 from. So your final number here would be 0.436. Again, sorry for the quality of the video and maybe shaking around a little bit, but I'm just learning this process. Okay, finally, the last thing we're going to do is, okay, let's say we don't have the outside diameter. Let's say we're looking for it. So we want to know the dash number 2, basically what goes inside this box. Again, because that's manufacturer's information. The 2024 is the alloy code. This one is missing the O, so it'd actually be -O. And then the dash number of the tube, or the outside diameter, and then the wall thickness. So this time we're going to work backwards. I'm going to give you the inside diameter. Let's say we took a tool and we measured across the inside of the tube and we got 0.561. What this question is asking, what would be the dash number of the tube? So basically, to determine that, we need to know the outside diameter of the tube. Same thing, right? Dash number relates to how many 16ths it is. So we would have to take the 0.561 inside diameter and basically add this wall thickness and this wall thickness, which that comes from right here. So the 0.032. So to solve this, I would have to say 0.561 plus 0.032, 1 wall thickness, 2 wall thicknesses, okay? And then I would add that all together, and I would come up with the final number of 0.625. Now, the problem is now that's in decimal form. So we need to figure out, to get a dash number of the tube, we need to know how many 16ths is 0.625. Well, if you convert 0.625 to a decimal, a fraction, you're actually going to get 5/8, okay? 5/8 would be the decimal equivalent of 0.625, but we need to know how many 16ths that is. So again, and this is kind of a review of our math skills that we've done all year long. So that would be 10/16. So your answer would be a -10 tube, okay? A -10 tube would be 5/8. The decimal equivalent of 5/8 is 0.625. Again, how I did that, I took the inside diameter, added 2 wall thicknesses to that, and I came up with 0.625. I took the 561 and added 32 thousandths on the top, 32 thousandths on the bottom, because again, if you measure across this diameter, you're going to have 2 wall thicknesses, and I get 0.625. But to get the dash number, I have to convert that over to how many 16ths, and 0.625 would be 10/16. So for the final answer here, I'd put a 10 in there. Okay, so anyways, you guys, I hope all is going well and that everybody's staying safe. Like I said, I thought the best way to teach this was with a quick YouTube video. This is not very long. It's a quick 10-minute video, but there's going to be a lot of questions on this type of stuff, and it's very difficult to teach this via just using verbiage or referencing you to the textbook or something like that. So I thought it would be worth it to show this in a YouTube video. So please take the time to watch it, and then also make sure that there's going to be practice calculations on these on the worksheet. Make sure you do those before you do any kind of a graded assignment, because that's going to help you out quite a bit in that. All right, thank you guys for watching. Bye-bye.